Okay, on problem 7, it says, what is the equation of a circle that has a center at -2, -2, -5 with a radius of 6? Well, the equation of a circle is x minus h, this is your h, and x minus a minus 2 would be x plus 2 squared plus y minus k, well this is your k minus 5, and y minus a minus 5 is y plus 5 squared equals the radius squared, so it equals 36. Here on the conics Excel sheet, we can put in the location of the center and the radius, and it will get it for us right here. Now on problem 8, it wants the diameter of the end center of this circle. So this is not in standard form, so we'd have to put in our coefficients going through here. So your A would be 2, your B is 10, your C is 8. Then your D is your number in front of the y squared, which is 2. Your E is -8. Your F is 2, and the constant at the other side is 100. So the diameter, let's go ahead and take a look at this. The diameter is, here's your radius, so your diameter would be twice that, so about approximately 14.866. And the center of this circle would be right here at -2.5, 2. And let's see, we'll go on to the next two problems here. Okay, on problem 10, it says graph this model. This is a piecewise defined function, and it asks, is the model a function, why or why not? Well, we'll graph it in just a second, but really to tell if it's a function or not, if I look at each individual part, they are functions by themselves. This is a polynomial, it's a quadratic, this is a linear equation, and this is just the top half of a sideways parabola, so everything by itself is a function. If you check the endpoints, you have to make sure they're the same. If I plug in, because they for example, 5, since it's equal to on both the first function and the second function, I got to plug 5 into both of these and see if we get the same value. If I plug 5 in here, I get 25 minus 15, which is 10. If I plug 5 in here, I get 10 plus 3. Well, that's 13, and they're not the same value. Again, plugging 5 in here gives me 25 minus 15 is 10. 5 in here is 10 plus 3, which is 13. So boom, these things are not functions. But I know you really want to see these graphs, so let's go ahead and graph these anyway and see what they look like.
Who the hell do you think you are?
I'm sorry, I want to graph these anyway, so let's do it. So I'll graph the first part here, which is equals x squared. I'm on the any graph sheet, minus 3 times x, and hit enter. And then I'll need to scroll down and click the get the graph there. And we graph this one from 0 to 5, it says. Let's go on over and graph the second one. The second one goes from 5 to 9. And let's type that one in. That would be equals 2 times x plus 3. And let's scroll down and click the get the graph here. And then finally, let's go over to the third one. That's clear over here. Put in its range, which is from 9 to 13. If I put that in, and now let's put in this function square root of x plus 5, well, square root of x can be written two ways. It can be written equals sqrt of x, parentheses x, or you could write it, if you don't like it that way, we could write it x raised to the parentheses 1 over 2 power, then plus 5. So either way, either square root of x or x raised to the 1/2. If I hit enter, and I go down here and click the get that graph, and that's from 9 to 13. If I move over now, I can see all the three graphs together. So let's take a look, and you can see we get different values right here for this, and also on the other one we get different values too. So it's definitely not a function, and that's what this piecewise defined model looks like. Okay, problem 11 says graph the model right here, and is the model a function, why or why not? Well, again, we only really need to check the endpoints. If we plug 10 in here, well, 10 minus 5 is 5. Absolute value of 5 is 5, plus 1 is 6. So I get 6 here. If I plug 10 in here, that would be 100 minus 90, which is 10, and 10 minus 4 is 6. So I get the same thing on this one. Now, how about this one? Since they're both 15 is part of both of these functions, I got to check 15 in both of these. 5 times 15 is 75. 75 plus 15 is 90. If I plug 15 into this quadratic, I could probably go to the quadratic sheet and do that easier. So let me go to the quadratic sheet a second and do that. So here on the quadratic sheet, substituting in my coefficients of 1, -9, and -4, and I'm checking that endpoint there of 15 to see if we get the same answer we got in this one. So let me substitute the 15 in for x. And if I do that, I get 86. And I think that's different than what I got when I substituted 15 in here, because I think I got 90 right there. Well, anyway, let's go ahead and graph these. Okay, so let's go ahead and graph the first one. It goes, I'm on the any graph sheet now. So the first one goes from 0 to 10, and that equation is, I'm going to type in equals, ABS means absolute value, parentheses, x minus 5, close parentheses, plus 1. Hit enter, scroll down to the, click the, get the graph, and we got the first one. Let's move over now and graph the second part. The second part goes from 10 to 15, and that equation was equals x squared minus 9 times x, don't forget the times sign, minus 4. Hit enter, scroll down, let's get that one, and let's go on over and put in the third one, clear over here, and this one is going to go from 15 to 20, and this equation is equals 5 times x plus 15. Hit enter, scroll down, and let's click the button. There it is. Okay, now let's see all three of these graphs. And if I look at all three of these, well, these ended at the same point, the first one, but the second one, they didn't end at the same point, and they both included the 15, so it's not a function just because of this one spot right here, but it is good practice with graphing piecewise defined functions. Okay, finally, the last one here on the practice test says graph the following equations and give the location of the vertex point, determine if the following equations are functions, and give the reason for your answer, and if it is a function, write it in function notation. This is a quadratic, so it's definitely a function. We could write it as f of t equals this, and the vertex point would be at 3, 5, and I think that's all they want on that one. This would not be a function because the y is squared. It would be a sideways parabola, and the vertex point on this, I believe, is at, well, I'll tell you what, we'll come back to this one. This is just a linear equation. It does not have a vertex point. This is just a linear equation. Again, even though it's solved for x, nothing is squared or anything, so it's just a linear equation, just a line. This is the bottom half of a sideways parabola whose vertex point is at 0 because there's no shift underneath the radical sign at 0, 2. So it's 0, 2, and it'd be the bottom half of it. This is a top half of a parabola that's opening to the right, and the vertex point would be at 5, 2. And this is the top half and bottom half of a sideways parabola, and the vertex point, it would be opening to the right, and the vertex point would be at -7, 2. So this is the only tricky one right here. So let's see if there's a place that we can solve this, and probably one of the easiest places to solve this. The easiest place to solve that problem would be just to refer back to our notes on section 1.5 where it says graphing sideways parabolas on section 1.5. And in case we forgot, if you have quadratics solve for y, okay, here's your h and here's your k, the vertex point is at -hk. But if you have vertex points solved for x and the y is squared, like our particular problem, then the vertex point is at k -h. So k on the x, -h on the y. So let's refer back to our problem now and see if we can figure it out. So this problem right here is in that form where the y is squared and the x isn't, and the vertex point is at k -h. So it would be at 5, -3 is where the vertex point is. Is it a function? No, it's not a function because it's a sideways parabola, and there would be more than one y for plenty of x's. It actually be opening up to the left because this coefficient is negative right here. So that really does it with the practice test. And that should do it right there.